So what you see here is that imagine that we just take one data point and we try to estimate its mean squared error based on the expected loss in a given region in the model input space. So kind of the similar idea that we had before, and we're gonna talk about how we can get that loss yet. That will come soon. But here what you see is that, let's say that we start with just one or let's say 5 data points. We'll get some kind of expected loss. We see it's 650, which is probably warningly high. But as we get more and more data, we'll see that actually this was not a representative sample. And we see that the actual MSE is high. And of course, even if I didn't kind of bit of bad fight, start with the points that are kind of on the verge of the actual data distribution, would get something that's a bit closer to reality, but it would still not give us a very tight and good and precise estimate of the current performance level. So we expect to see a lot of noise if we just sample one or few data points when it comes to our performance estimation. So what we should do instead is we should gather enough data points to have a good representative sample of our current data distribution. So we need to aggregate our data to really get a good performance estimation metric. We do it, generally speaking, by chunking our data in daily, weekly chunks, maybe monthly chunks, or we can also just say to aggregate data by every, let's say, 10,000 data points and estimate the model performance for that current chunk of data.